Welcome back to my Smart Learning. This is a lesson for Year 10s. We're carrying on with our physics lessons on electrical circuits. Last lesson we looked at mains electricity, how electricity gets to your homes. What we're focusing on now is your 3-pin plug. So, learning objective, how do plugs work in my house? So we always start with a quick recall PT. High five quiz, you get all 5 correct, you get a high five from me. So number 1, what does DC stand for? Number 2, what does AC stand for? Number 3, what is the voltage on your mains electricity at your house? What is the voltage of your live wire, which is different to your mains, and the network of wires across the country? What do we call that? The network of wires across your country. So DC stands for direct current. So if you paused or if you had a go, DC stands for direct current. AC stands for alternating current. Mains voltage is 230 volts. And your live wire is 325 volts, and your network of wires across the country is known as the national grid. That's your national grid. So if you got all 5 correct, excellent, well done. You get a virtual high five from me. Well done. Now, we're looking at 3-pin plugs. So before we look at the plug in itself, there is another YouTuber video attached to this of me actually wiring a 3-pin plug, which is useful for you to watch. Now you'll notice in the other video there was no earth wire, but this is what it should have looked like if there was an earth wire in there. It kind of surprised me that there wasn't one when I was wiring up my vacuum cleaner the other day. Right, so here is your cable, or your flex we call it, and if you do a cross section, if you cut through it, you'll see you've got a brown wire, a blue wire, and one that's covered with green and yellow insulation wire as well. And you've got copper wires running through them. Okay, so that one is your live wire, the brown one. The blue one is your neutral wire, and the green and yellow is your earth wire. So this is what it looks like. So as I got my my plug for my Dyson, I snipped through the wire. That's what I saw. Okay, well, I didn't see that, that was missing. But then I had to strip that back, so that's why I had to score a little bit of this insulation on the flex or the cable, so that I can expose these 3 cables inside. So what's in your 3-pin plug? Your 3-pin plug have 3 pins, obviously. And they're made from brass. The reason why it's made from brass is a lot more stiff and harder than your normal copper, because copper is a lot more flexible. But brass has got it's an alloy, so it's a mixture with copper with other metals in there, and that makes it hard, but still a good conductor. Whereas copper is more flexible, it's still a very good conductor. So my flex or my cable has to go through there and connect to the internal workings of my plug. Why do I have a plug? All of your electrical appliances, the ones that are connected to the mains electricity, have to be connected via a plug. The things that don't need a plug are the things that are working on battery power. So if I strip back my cable, the outer casing of it, or the outer plastic, you've got your 3 wires inside. What are they? You've got your live wire, which is the dangerous one. How to remember it? Well, that will be the colour of your coffin if you ever touch the live wire, or the colour of your pants if you've just pooed yourself because you touched the live wire. The blue one is your neutral wire, and the green and yellow one is your earth wire. Well, the electricity comes from my electric company, through the electric board, through my live wire. It'll go into my TV, then it'll come out of my TV into the neutral wire, and then the neutral wire will go out the pin and go back into the socket and then out to the substation. Earth wire is not actually connected to the circuit as such. The earth wire's purpose is purely for safety precautions, a safety measure. Okay, so the AC, the difference between positive and negative, happens in the live wire. The neutral wire is a thing that keeps it at the 0 voltage. Okay, that's why it's called neutral. The earth wire is your safety wire on your appliance. If that, it should be touching the metal part of any electrical appliance in your home. And if my metal part becomes live, because for some reason there's been damage to it and the live wire is exposed and touching the casing of my appliance, my whole appliance becomes live. If I touch that on my laptop and it's live, the electric current will go through me, and I'm technically earthing it, it'll go through me into the ground, and I'll be the one that being the electric shock. Whereas if you've got a live wire, instead of it going through you, electricity always tries to find the easiest route. And the easiest route is the one that's got the least amount of resistance. I've got more resistance because I'm not a metal, so I'm a poor conductor, compared to the earth wire, which has got copper in there, so it's got the least amount of resistance. Instead of going through me, it'll go through the earth wire instead, and it goes into a metal plate outside your house. Okay, so it withdraws it. Now you've got what we call residual circuit breakers in your house that if you should do anyway. So if you get a surge in electric current because there's something going wrong in your house, like somewhere being electrocuted or there's a surge in power, the residual circuit breaker flips a switch and everything in your house shuts down, and that's to protect people from getting electrocuted as well. So here's a socket, double plug socket there. You'll have the live wire coming through one way and the neutral going out the other way, and you've got your earth pin at the top, your switch there. Now what you'll notice, like in the previous video, is that the earth pin is longer than the two pins at the bottom. The reason why, it goes into that first, and there's a little switch in there where it lowers the lever, and by doing that it actually lifts up, because these two guys at the bottom are covered with a plastic cap. The reason for that is so that nobody goes around sticking metal objects into there, because if a child goes, for safety reason, goes and starts poking it with a metal screwdriver or a knife or something, bang, they'll get a massive electric shock and they'll die. Okay, so that's your sockets, and that's pretty obvious. You get your plug and you stick it into your socket, into your 3-pin plug socket. Now not every country has 3 pins. In other countries you might just see there might be just 2 little round pins at the bottom, but the UK has some of the highest standards in the world for electrical standards. You're not even allowed to change your electrical switches for your, let's say, light switches, or even that. You're not allowed to go and open one of those up and put a new one on. Most people can do it, or a lot of people can do it, but technically you're not allowed to, because everything has to have certification, especially when you sell your house. So, quick little quiz here for you. See if you can match up the right word with the right thing. So, it's a good conductor and flexible. Well, we know that the pins are good conductors. The plug isn't, the casing isn't. That's why it's made from plastic, a stiff plastic. And the flex is made from a softer plastic, so it can bend. But the wires need to be able to bend. So, the good conductor and flexible will be, that's the good useful property of it, of the wires. Well, which one's made from brass? We remember it was the pins. The plastic is the material that makes the plug case, which is the useful property. It's a good insulator, so you don't get electrocuted. The copper is what's made by the wires, and good conductor and not flexible is your pins. So there we go. Right, what does a 3-pin pin look like? If I open up the casing, you'll see, open up the casing, you've got a cable grip or a cord grip there. You've got your earth wire goes into the top pin, your live wire goes into the bit next to the fuse, so that's your live pin there, and your neutral wire goes into the pin that's got nothing attached to it. It's the one on the left hand side there. So that's the correct way to wire a plug. Now I've gone through a whole video of how to wire a plug correctly, so watch the other video, because that goes, you can actually see me physically doing it. And in your lessons back at school, you'll get an opportunity to do that when you do, when you're back at school, obviously, because you've got the equipment there. So we're just going to just make sure that they're in the right terminals. You just have to make sure that there's not too much wire exposed. So you've got enough plastic there, there's no out there, you've got to make sure it's not covering that so the screw can go in. You make sure the fuse is there. The fuse is a safety device. Inside there is just a thin piece of wire within a ceramic case or a glass case, and you've got metal caps there. So electricity will go through the fuse and then into your live wire and then into your appliance like your TV, then out of your appliance, then out the neutral wire, then out and then to your substation. The earth wire is not actually needed, it's only there as a safety device. And what's inside the fuse, which we'll do next lesson, it's just a thin piece of wire. If too much current goes through there, it melts and it blows and it stops the whole circuit from working. It's a very cheap part of your circuit just to as a safety device, so that the wires don't melt, causing a house fire. You don't get electrocuted because too much current is flowing through your circuit. So, what is the correct colour for each wire? So you should know this one based on that. So what should we have for, let's say, let's go for our live. What colour is our live wire? Well, obviously it's going to be brown, because if you touch that one, the pants might be brown. And what about the neutral wire? Neutral, like the sky, is going to be blue. And then your earth wire, the colour of the grass, is green. So it's going to be the green and yellow. Well, it'll be yellow if the grass is dying because there's no sun. So that's the first thing you should know. And you've got to remember the cable grip there has to hold the cable. You don't want that exposed there, and you've got these three wires under that bit there. So what's wrong with these plugs then? Very quickly. So I have to click a part of the plug that is incorrectly wired. So based on my last video that you should have watched of how to wire the plug, or if you haven't watched it already, watch it straight after this video. Here are some plugs you're going to see on the next few slides. What is wrong, or how are the plugs wired incorrectly? So I've talked you through on the other video of the correct method of wiring a plug. So, oops, not that one. That's question 1. That's not right. Let's just restart that. So if you notice, what can you see is wrong? That one's correctly done. Right, what's wrong with that one? So if you look carefully, spot the mistake, spot the difference compared to the first picture. What you should notice is this one has got a fuse missing. I'm going to click it there. So there's no fuse there, so fuse missing. Everything else seems correct to me. Okay, next. What's wrong with this plug here? Well, the fuse is now there, the wires are in the right place. What looks wrong, if you notice, you should notice that the neutral wire isn't connected, so the circuit isn't complete. So the neutral wire is not connected. Okay, next. What about this one? What's wrong with that one? Have a look carefully, press pause if you're not sure. And then start back. Well, what's wrong with this one? If you notice, there's too much copper cable exposed here. It's been stripped far too back, so there's a chance of some kind of electrocution or short circuit into there. Okay. Check that one. Did that one, yeah. And then next, what's wrong with this one? Well, if you notice, everything's wired correctly except for the earth there. The earth isn't wired to its terminal, so again, there's a danger if the whole case becomes live, you can get electrocuted. What's wrong with this one? Everything's wired up correctly and we've got a fuse, but the cable grip is missing. So you've got the cable grip missing there. And there's more. Right, what's wrong with this one? Well, this one again is pretty like compared to a previous one. We've got too much wire exposed there as well. Okay, you should have more insulation because you can end up having a short circuit or get electrocuted. Okay, so that's your plug, how to wire a plug correctly. Right, so what about this? Quick true, false. A live wire is coloured brown. Is that true or false? Well, keep mentioning about colours of certain underwear if you touch a live wire. That is true. The earth wire is coloured blue. No, the earth wire is green and yellow, so that must be false. The neutral wire is coloured blue. Yes, the sky. It is safe to remove the insulating plastic coat from the earth wire. Is it safe? I don't think removing any coating from any wires is going to be safe. An appliance only requires a live wire and an earth wire to work safely. Well, there's a wire missing from there. The neutral wire you need as well. You only technically need the live and neutral for it to work, like I showed you on my Dyson vacuum cleaner. There are other models available, by the way. The earth wire is just purely there's a safety aspect of it. The cable grip stops the cable from being pulled out from the plug. So there we have it. So fuse then, what's the purpose of the fuse? Now we're going to do a whole lesson about the fuse in our next lesson, which will be next week. We're going to look at the purpose of a fuse and how you can work out which fuse to use. But here's a few words for you to work out. The fuse is a safety device. What I'd like you to do is pause the video, write that out. There's the words at the bottom there. See if you can work out which words go into those spaces there. Okay, and that's the purpose. The fuse is, like I said, is a safety device. It's just there to stop your circuit from overheating, stopping fires, stopping you from getting electrocuted. So if you press pause, have a go, and then I will go through the answers now. So fuses are safety devices. If there is a fault in an appliance which causes the live and neutral or the earth wire to cross, if they touch, then a large current will flow through the fuse and cause it to melt. This will break the circuit and protect the appliance and user from further harm. Okay, so if you missed that, press pause, rewind, and go through that again. So that is pretty much coming to the end of our lesson. The last thing is just the earth wire, looking at the earth wire in a bit more detail. So have a go at writing that out. There's the words at the bottom, if you can see them. And then press pause, write this out, see if you can work out which words go where. And I'm going to post the PowerPoint with the video on Show My Homework, so you've got it already there ready to use. Now, somebody did ask me the other day, why have you sent us a 100-page PowerPoint? It's because I've got all the slides on one PowerPoint, so it's the different lessons on different stages, so you don't have to use the particular slides that are with this particular video with that particular lesson. So if you've had a go, if I've pressed pause and had a go at writing that out, what are the earth wires for? So we've got the word fuse, fault, metal, surge and touch. You can see that's an earth wire there touching the outer case. That will take the current away from that circuit. There's your earth wire there. So earth wires are always used in an appliance if an appliance has a metal case. So always used when you've got a metal case. That's the reason why the Dyson didn't have the earth wire, because the Dyson's fully made from plastic on the outside. If there is a fault in the appliance causing the live wire to touch the case, the current surges down the earth wire and the fuse blows. Okay, so there's your answers to that. So that's the end of the lesson about plugs. Next time on My Smart Learning, we're going to look at the fuse in more detail, in more particular, how you work out which fuse to use with a particular appliance. And we're going to look at another formula on how you calculate electrical power. Hope that's been useful. Please, watch the videos, share the videos, like the videos, and I'll see you next time on My Smart Learning. For year 10s, it'll be next week, or we're going to be looking at fuses. Take care and see you next time. Bye.